Hey guys, welcome to our last lesson of the entire year. So congratulations, you guys have made it. I am so proud of you. You guys should be proud of yourselves. Okay, this has been an awesome class and I can't believe that here we are at the very last lesson. I wish I could see you guys in person, but I know you guys are still rocking it. So let's get through this and let's get to our last homework assignment. Today we are finishing up with lesson 4-5, day 6. We're still going to be dealing with exponential and logarithmic equations and solving, and it's kind of going to be a wrap-up of everything we've been doing in chapter 4. So bringing in some of those formulas that we've discussed, change of base, things like that. So let's jump right in. The first formula that we're going to be using directly in today's lesson is the compound interest formula. Now you guys have seen this formula before. It was on your quiz, but just a reminder of what all of these letters represent. A is going to be the ending amount. P represents the principal, which is a financial term for the beginning amount. R, of course, is the rate, but please remember that the rate has to be a decimal. So if for whatever reason we're told that the compound interest rate, let's say, is 8%, to turn that into a decimal, remember we have to move the decimal point 2 places to the left. So we would really write the rate as 0.08. Okay, guys? So please keep that in mind. We always have to turn our rates into true decimals. The letter M here represents how many times the interest is compounded per year. So again, if it's compounded monthly, that's going to be 12 times per year. If it's compounded daily, that letter M would be 365 because it's compounded 365 times a year. If it's compounded annually, that letter M is just going to be 1 because it's just compounded once per year. Okay? And then the letter N up here, our little exponent, that represents the total number of compounding periods. So for example, if it's compounded for 20 years, then you're going to have a lot more. So let's look at our next review formula, and this is going to be the definition of log. Okay, so remember, we need to be pros at switching between logarithmic form and exponential form. That's going to be a huge part of the test, and it just has to be second nature for us at this point, being able to go between one and the other. Okay, so here is the true definition. Notice that the log base, okay, whatever the base of the log is always the base of the exponent as well. All right, so let's start here with this example because it usually is a little bit easier to attach some concrete numbers to it. So here we have logarithmic form. Let's rewrite this in exponential form. Okay, so the base of the log, that 10, is going to be the base of the exponent. Whatever number or letter is by itself on the other side of the equal sign, that's going to become my exponent. So I would have 10 to the power of x equals, and then whatever number you are taking the log of, this is going to go by itself in exponential form. So we would have 10 to the power of x equals 1,000. And there would be our final exponential form. Okay, guys, so I think you have all gotten a lot more comfortable with this, but this is a little bit of review for you just in case. Let's go into the first homework example. We have a total of 4 examples for this PowerPoint, okay? So we're dealing with compound interest. How many years to the nearest year, so we're going to be rounding, will it take a sum of money to double if it's invested at 15% compounded annually? Now, here's a bit of the problem. The only variable that they're giving us is the rate and the M, how many times it's compounded. So that means that we are left with 3 variables that we don't know. They're asking us to find how many years. So how many years is going to be here in the exponent, because that exponent N represents the total compounds, all right, or the total time. So this is what we're looking for. For A and P, what do we do with that? Here's our super important hint. Okay, guys? We're just going to plug in numbers. And this is those of you that have taken the SAT and those of you that are going to be taking it. This is so important. This happens in the SAT all the time. If they don't give you concrete numbers, pick your own. Okay? So I'm going to erase a little bit here so that we can go ahead and start picking our own numbers. All right? Now, the numbers that we plug in have to make sense. All right? We can't just pick any numbers out of the blue. If they tell us that the amount of money is going to double, so for the ending amount, let's say that I'm going to pick 20. So for the initial amount or the beginning amount, what would that have to be? 10. Does that make sense? So yes, I'm plugging in numbers, but it's still numbers that are true to the problem. All right, I started with $10 and it doubled into 20 by the end. Let's keep going. 1 plus r. They tell us the rate is 15%. Remember to make that 15 into a decimal. We move the decimal point over twice. So I'm really going to write 0.15. M is how many times it's compounded per year. If it's compounded annually, how many times is that per year? Once. Okay, if you go get a physical annually, you only go one time a year. And then the letter N is the total number of compounds, and that's what we're looking for. Okay, that's the time, so I leave that there as my variable. All right, let's get to solving now. Okay, the first thing we want to do is get rid of this 10 because this 10 is separate from my parentheses, and I want to leave my parentheses with the variable all by themselves. So since the 10 is being multiplied, then the opposite operation would be to divide by 10. So I'm going to divide both sides by 10, and I end up with 2 equals 1 plus 0.15 over 1 to the power of n. Okay? So now I'm going to come up here and keep going with my work. I'm just going to simplify my parentheses. I'm going to have 2 equals 1.15 to the power of n. So I just simplified there. From here, and this is the whole point, guys, of why we use log. If you need to find an exponent, you have to use log. There's no other way to solve for that exponent. That's why we're learning log this chapter. So I'm going to rewrite this in logarithmic form. So I'm going to do log. The base of my exponent becomes the base of my log. So log base 1.15 of 2, because whatever number is by itself is what I take the log of, equals, and then my exponent comes over here all by itself. So this is what it would look like in logarithmic form. Log base 1.5 of 2 equals n. Now this is super easy from here, right? Remember, we just go into the calculator. Default log is base 10. So since this is base 1.15, remember in the calculator we have to hit that math button and then scroll down till you can change the base. All right? And so once we're able to just put that into the calculator, we end up with n equals 4.96. Now the directions did say to the nearest year, okay, and it will show up this way on your test as well. So make sure that you actually tell me the final answer of 5 years, okay? Because 4.96 would round up, and so this would be your final answer to this question. Okay, guys? How many years will it take the money to double? It will take 5 years. Alrighty, here is our next formula. And again, we've seen this before, but just a review. The continuous growth formula, so notice we are growing here. P is the ending population. P sub 0 is the initial population, okay? Remember, we call this P sub 0 because we have that 0 down there. R is going to represent the rate, as always. it has to be a decimal, and t is just going to represent the time that has passed. All right? Remember that letter E is a constant. It's in the calculator right next to your, well, I guess it's the division symbol. So in order to get the letter E, you do second and then the division symbol. Okay, so that's just a constant. It's nothing that we plug in for that. Let's go ahead and use this now in an example. So homework number 89. There were 10.5 million illegal immigrants in the US in 2005. That number grew to 11.3 million by 2007. We have a two-part question now. For part A, find the relative growth rate if we use the P equals P sub 0 e to the RT for population growth. Round to 3 significant digits. So what they want us to solve for is this variable of r. So what do we have to do? We have to plug in. Now they do give us values. 10.5 is what we're starting at. 11.3 is what we're ending at. So let's go ahead and plug that in. So for the letter P, I'm going to put 11.3. For P sub 0, I'm starting at 10.5. I just leave my letter E there. Remember, R is the variable that we're looking for, so I leave R just like that. Now, how much time has passed? If I went from 2005 to 2007, that means 2 years have passed. Okay, guys? So now I have set up my equation, and now I need to solve to find rate. So the first thing I need to do is get rid of this 10.5, okay? Because e to the power of r times 2 has to be by itself. So how do I get rid of that 10.5? I divide both sides by 10.5. And so when I divide both sides there by 10.5, I end up getting 1.07619 equals e to the power of 2r. And notice I'm just rewriting that in standard form, right? Normally in mathematics, we write 2r instead of r2. Alrighty, now I need to solve for my exponent. So remember, how do we always solve for an exponent? We rewrite this in logarithmic form. So to rewrite this in logarithmic form, I'm going to do log. The base of the exponent becomes the base of my log. The number by itself is what I'm taking the log of. So log base e of 1.07619 equals, and then whatever the exponent is goes over here by itself. So now I have logarithmic form, okay? Now, remember that log base e is the same thing as writing ln, the natural log. So I really have ln of 1.07619 equals 2r. And so my final step to solve here for r is just divide both sides by 2, okay? And so when I divide ln of 1.07619 by 2, remember that ln button is just to the left of the number 4 on the calculator, okay? And so when I put that into the calculator, I end up with a rate of 0.0367. And it might show up like this on your test, but in case it shows up as a percent, remember we just work backwards and move the decimal point to the right this time. So as a percent, it would be 3.67%. So be aware that on the test multiple choice, it could show up either way. But there we go. In the bottom left, we have an answer for part A, the rate. It would be 3.67%. Okay, guys? Now let's go to part B. Use your answer from part A to write a function describing the illegal immigration or the illegal immigrant population. Use this to predict when the illegal immigrant population should reach 20 million. So basically, this is my equation, the P equals P sub 0 e to the RT. I'm just going to plug in what I know from example A, okay, or from part A. So the ending amount is what I don't know. I do know the beginning amount, 10.5, so I'll put in 10.5 times e. I know the rate now, which is 0.0367, and then I just leave the time as time. So if they ask you to just write a function, this answer here in red is the function, okay? But now we're gonna keep going with part B, which says predict when the population would reach 20 million. So what am I gonna plug 20 million in for? I'm gonna plug it in for this ending population, all right? So I'm going to have 20 equals 10.5e to the 0.0367t, all right? My first step to solve is divide both sides by 10.5. So when I divide both sides by 10.5, I end up with excuse me, I miswrote there. So 20 divided by 10.5 is going to give me 1.90476 equals e to the power of 0.0367t. To solve, I need to write this in logarithmic form. So I would have log base e of 1.90476 equals 0.0367t. And so my last step to get t alone is to divide both sides by 0.0367. So divide both sides by 0.0367. And so when I do that, what I end up getting for my final answer for t is I get t equals 17.6. Now, this is not my final answer, and this is not what's going to show up on your test, because the question asks us, when is the population going to be 20 million? So you can't tell me 17.6. So what do we have to do? If we started in the year 2005, take 2005 plus, take 2005 plus 17.6. And so what would your final answer be? In the year 2022. So this would be your final answer to part B, because now you're telling me when we would reach 20 million illegal immigrants. Okay, guys? And that's how it's going to show up on your test. All right? So we're halfway done. 2 out of the 4 examples. And this was the long one. 2 parts. All right, our next example here. A mathematical model for the world population growth over short periods is given by p equals p sub 0 e to the power of rt. How many years to the nearest year will it take the world population to double if it grows continuously at an annual rate of 1.14? So this is very similar to the first example we did. Okay, again, if they don't give us concrete numbers, let's plug in our own numbers. So for the ending number, I'll put 20. For the beginning number, I'll put 10. Again, you could pick any numbers you wanted to, as long as they actually doubled. Okay, you could pick 10 and 5. You could pick 2 and 1. All right? 20 and 10 are just nice, easy numbers to work with. Then I'm going to have E. They tell me the rate, so I move the decimal place over twice, and I'm going to have 0.0114. And then T is the variable I'm looking for, right? They're saying, how many years will this take? So I am looking for time. So from here, my first step, remember that E is to the variable, right? E has the variable in the exponent, but the 10 is not part of that. So we need to get rid of the 10 first. So how do I do that? I'm going to go ahead and divide both sides by 10. So let's divide both sides by 10 here. And now I have 2 equals e to the power of 0.0114t. Whenever you have a variable that is in the exponent, you need to rewrite this in logarithmic form. So to rewrite this in log form, I'm going to put log base e of 2 equals 0.0114t. My last step to get t alone is divide by 0.0114. So divide both sides by 0.0114. Remember that log base e is the same thing as saying natural log or ln. So I really have ln of 2 divided by 0.0114 equals t. And so when I do that in the calculator, I get t equals 60.8. Now that's still not my final answer because they tell me to round to the nearest year. So your final answer, what will show up on your test, is 61 years. Okay, guys? So there's our answer to example 3, our third example here, homework 91. You would tell me how long does it take to double? It takes 61 years. All right, the last formula we're going to be looking at in this lesson is half-life decay. And again, we've worked with this formula before. It's the time that it takes for half of something to disappear. A is going to be the ending amount. A sub 0 is going to be the initial amount. Notice half is part of the default equation because we're working with half-life. T is the time that has passed. And then H is how long the half-life is. All right, so is the half-life 2 days? Is the half-life a week? All right, the problem will have to tell us that, or we might have to find it. So now let's put that formula into practice here with our last example, guys. The last one of the year. I'm getting a little emotional over here. All right, so a medical researcher is testing a radioactive isotope for use in a new imaging process. She finds that an original sample of 5 grams, so that means this is what she started with. She started with 5 grams. It decays to 1 gram in 6 hours. So that means that 1 gram is the ending amount, okay? We have the original amount of 5 grams, the ending amount of 1 gram. They want us to find the half-life of the sample to 3 significant digits. So let's start plugging in. For A, the ending amount, I'm going to put 1 gram. For A sub 0, the initial amount, I'm going to put 5 grams. The 1/2 is just part of the equation. T, the time that has passed, 6 hours have passed. So I'm going to put 6. And then H is the half-life, and that's what they want us to find. So I'm going to leave H as the variable. Okay, so in order to solve for H, remember, it is only the 1/2 that has the exponent to it. So we want 1/2 in the exponent all by itself. So to do that, I divide both sides by 5. All right, so now I have 0.2 equals 1/2 to the 6 divided by H. And now, like we've been doing, whenever there's a variable in the exponent, you need to rewrite this in logarithmic form. So I'm going to do log base 1/2 of 0.2 equals 6 divided by H. Now, if we have log base 1/2, remember in the calculator, you have to go to that math button, okay? Because the default log is base 10. So once we do log base 1/2 of 0.2, then we get the number 2.3219 equals 6 over H. So what do we do not to solve? To get rid of the denominator, multiply both sides by H. All right, so here they cross out, and now you have 2.3219 times H equals 6. How do I get the H alone? Divide both sides by 2.3219. 2.3219. And so what I end up with is H equals 2.5 hours. So what is the half-life of this isotope? 2.5 hours, meaning that it takes 2.58 hours for half of it to disappear. All right, guys? And that is our last example, if you all can believe it, okay? So that is it. Here's the last homework assignment, okay? After this, we only have things like test reviews, exam reviews. So on page 450, notice you only have 4 problems. Please be careful on number 90. Only do part A and part B. If you try to do part C, you're going to get confused, all right? And here's just a little update on what's going on with our test. All right, you'll have the rest of this week. So this is the homework due on Monday. You'll have the rest of this week to work on your test review. So that's a typo. Rest of this week to work on test review. Your test review is due on Friday, May 1st. And then the answer key will post over the weekend. Monday and Tuesday is our test. Notice it's a 2-part test. So the first 20 questions will be Monday. The second 20 questions will be Tuesday. There will be an optional review on Sunday, okay? So an optional live review on Sunday, May 3rd. The link is already listed in Google Classroom, so if you guys want to join that review, you can. And thank you guys so much for joining me with all these lessons with distance learning. Again, I just couldn't be prouder of how you all have handled yourselves. And I will see you in our live classes and our live reviews. Thank you all so much.